We're still looking at comparing two means. I've given you a couple of pre-versions of this testing of two means. Here is, you could say, the most classical version of testing two means, which is the two-sample T-test, as it is called. It is basically almost as before, however, with a little twist, with a little difference that comes, if we look at the test statistic that compares the two means, we have now, if you look at the variances, I have not plugged in one variance and the other variance. That could be done, and we'll get back to that, but I introduced this one first as the most classical one. Instead, I have plugged in SP squared, which is a combination of the two variances, you could say. It is a weighted average of the two variances, generally. It takes the one variance and the other variance. And if there are equal amount of numbers in the two group, and one equal and two, it's simply the average of the two variances. If we use this, the T-Test Statistic, it becomes a T, that's the first result, like 2 weeks ago. And the degrees of freedom to be used, the T, the relevant T statistic, is the one with the sum of N1 and N2 minus 2. That is N1 minus 1 plus N2 minus 1. And we have a sort of critical value table exactly as before, but with all the sets substituted by t's. So it's just, as I would say now for the rest of the course, do the hypothesis test exercise as usual, just use the t here. Now we should do it, I think. We have our little example that I introduced in the beginning with the secretaries and the nurses. Let's try to carry out hypothesis test, whether it's the same. So I would start out by writing the hypothesis test. I would write it like this. And if we should put it in the form that we have seen a second ago, that's the same to say that the difference of the means in the two groups is 0. That's the null, that's the claim. What about the relevant alternative here? Yeah, that's another one of those situations that might not be so easily decided. Actually, what we should do to try to find what is the most sort of correct choice of alternative that fits the situation in the right way, we should step back to how the situation, since we don't know the situation really, we only have a very short description of the situation given by these words that I told you at the beginning. Let's try, if now I give you, this is a bit, you could say, exercise technical or strategic for you to say, is there anything? No, let me start by saying, if there is no information at all about anything, like if you didn't know anything about secretaries and nurses, if it was blah blah blahs and blee blee blees you were comparing, and you didn't know what the heck they were doing, you had no information whatsoever what this was all about, the default in what you want to do is the two-sided, right? If there is nothing that calls for something to be one-sided, the default setting is two-sided. That's also by the R procedures. That's what the functions are doing. If you tell it nothing else, it will assume that the two-sided. And that makes sense in the fact that if you don't know anything, then you just have to say, if it's too much to one side and too much to the other side, I will reject that it is this. So you need some more information, some more sort of that tells you that the relevance is only to one side or the other side. It needs some additional information or setting. Here is the key sentence in the description here. Whether we could have some prior sort of thoughts and expectations, of course, and knowledges about what we think of the situation. we may bring in some knowledge, but here is the knowledge that we are supposed to look at that is given to us in the exercise story here. Here it said, the secretaries are expected to have a sedentary job. It's a long time since I used this word. I guess it means a more calm job. Sedentary, that's something when you get... Yeah. Anyway, while the nurses are expected to have, that's more understandable for me at least, a more physical, demanding job, right? That's the key words to us to say, I'm expected to do a one-sided hypothesis test, where the only alternative to them being the same is that the nurses use more energy, right? So that's a kind of how we should read this. Here the additional information was given to us. Okay. They want me to do a one-sided. Then I have to again decide what is, why don't we say this is, the secretaries are 1 and these are 2, just to try to keep, I mean, we could decide either way, we just have to, again, be clear on what we do. So that means the secretaries, nurses are the second one. That means I would say that the alternative would be that the nurses is higher than the secretaries, right? That it is negative if I have kept my tongue straight in my mouth correctly. I think I have. So it's a one-sided to the left situation. Please note that I made this decision, I made this whole sort of fixing of the alternative for the situation without looking at the data, right? It's not, has nothing to do with the data as they come. It has only to do with the setting and the story and the understanding of the situation. That is the, I mean, and that can be some of the challenging parts sometimes, but I would say for most of the exercises and that I give you, it's not so difficult to make a decision, and very often the decision was already made for you. So it's not, of course it's part of our course, but it's not like it's 80-90% of all exercises you have to do, where you have to sit and think about this. I may force you to think about it, but not 90% of the time, right? Okay, let's try to do the hypothesis test. In order to compute the T-Test statistics, well, then I should do all the computations first. I had n in one group, n in another group. Then I need to do these computations, S1, S2. I'll do those in R. I prepared. Here's the secretaries and the nurses, right? Just look at, for me to remember which is number 1 and which is number 2, secretaries and nurses, yes. Then I could compute the mean in the two groups, the standard deviations, and if I wanted, I could also compute the variances. So I have them here also, so I don't have to remember, which I realized it's impossible for my brain. What is left of my brain? Your brain capacity is on average a considerable number of percentages higher than mine, compared to, compared relative within yourself, of course. It's your personal max is now, right? So enjoy it. It's only going like this as of here, right? Then you have to work on some other skills, like experience and other things. But hey, how sexy is that? But so enjoy your max performance, right? It's there, so you should enjoy it. like this. Then, to use the T-Test statistic, I should plug in this. I have if N1 and N2, and then I should plug in this SP. What was SP? P is for pooled. That is, you pool the information of variability from the two groups. You put that into a common pool, into the same pool. That's why we sometimes call it the pooled T-test. That is, we take 8 times one variance plus 8 times the other variance divided by 16. That is, in this case, just the average of the two. I was using the formula for this joint or pooled variance. If I plug in the two numbers here, I get a pooled variance of, I don't even have the variance value here. I have, yeah, I do actually, like this. It's 1.9967, like this. And then the standard deviation is 1.14, that is the square root of this. You can see the 1.14 clearly. It so happens that when I round, it's actually also the average, but it's not as such the exact average of the standard deviations, but of course it will be in between these two, and very often sort of maybe close to the average of the standard deviation. Strictly speaking, we compute the average on the variance scale, and then we take the square root afterwards. But it will be in between, of course, the two standard deviations. So that was the 1.997. I should take the two averages in this case. I have taken 8 like this, 10.30, and I should subtract delta, which is 0 here. So here's the T-test statistic, which becomes minus 3.017. The difference between the two means on a standardized scale is 3.017, or minus 3. Is this a large or a small difference? Should we reject or should we accept the null of those being the same? What is your gut feeling? A t-statistic of around minus 3? Is that a large deviation or a small deviation? Like, I mean, before we start being exact on the degrees of freedom and everything? Is 3 a large or a small deviation on a standardized scale? It's a pretty large one. Maybe not extremely large due to, but at least usually we have this plus minus 2 thing in our, we should have that in our guts, right? The plus minus 2. I mean, we cannot use that in all cases. It depends on one and two-sided and all and the degrees of freedom. So of course we should be a bit careful here. But my gut feeling about a deviation of 3 is, it's pretty big. But let's be exact about it now. Let's be exact. The thing is, we are looking at a one-sided alternative to the left. And if you remember from my slide, we should, and we use 5%, the most commonly used, we should find the 5% critical value of the t-distribution. If I jump back just to show you in the table exactly where I am in this situation now, right? I'm looking at whether my computed t is too much to the left compared to the 5% point of the t. Am I there or am I not too much to the left if I do the critical value way of finishing my story? So the question is, to see, we should make a decision now. My observed, my computed minus 3 deviance, is that in my acceptance region or is it in my rejection region? The critical value is important here. What is the critical value of this t? I can find that in table 4, or I can find that in R, right? I could find the T, the 95% point of the T, using how many degrees of freedom? One, two, three. Yeah, what was that? 16, exactly. 8 plus 8, that's what the formula said a minute ago. 16. We could also, if we had taken the 5% point, we would have gotten the left-hand point there. So it's minus 1.746. Minus 1.746. So now I can make my decision, right? Because my computed T is, since the minus 3, 0.17 is further out to the left compared to the critical value, I do what? How many things I should accept it to be a fair deviation? It's not pretty big. I accept the null. I'm not too far away from the null to accept. Are you there? It's not good on my heart condition. I don't have a heart condition, don't worry. I'm not gonna die on you here. Are you still there with the sound also on the no sound? We'll just give it a sec. See if I'm back in business. Come on, come on, come on. Oh, come on. Come on, let's try to put at least the sound on. Sound is there? That's the important part. So, and sharing screen is also important. I knew it was going to be one of those days. My bike went flat on my first attempt of getting here this morning. So I went back on a flat bike, changed shoes and changed bike into my nice bike that is not supposed to go out in the rain, and went on, almost being killed because I have no light on my nice bike, and now this. Sound? What's that? You? Sound is there? Should I or shouldn't I? I don't dare to, I'll do it. I'm sorry, I'll do it. It looks okay now. Please, whoa. Yeah. Start sharing. Okay. Whew. We are there, back in business. We should, now I'm not going to do any voting here, I'm just going to tell you the results. Voting time is over. We reject the hypothesis because we are too far out. We are in the rejection region. We have a too large deviation. Good. Now, we could have gotten this also easily in R. Let's see if we do it correctly now. If I use the t-test function, plug in the 2 columns of data, actually I need to emphasize something which I'll get back to, if not today, then next time. I have to emphasize this about var equal. It means that this one tells the procedure, go pool the two variances into a joint variance, the SP. If I don't write this equal, var equal to true, it will separate out and do a slightly different version of the t-test, which I haven't shown you yet. I'll get back to it next time. To get the exact version that I have shown you now, we have to write this. And then I should put the alternative, because if I put nothing if I don't put any option on the alternative, it would just use the 2-sided option. And I was going to make a one-sided test in this case. Here it comes. 2-sample test, t-test. The t, as I've computed it, the degrees of freedom, and the p-value. Now it found the p. I didn't find the p-value from before. I could have found the p-value by finding what is the probability to the left of minus 3.0091 using a t-distribution with 16 degrees of freedom. What is the probability of being even more weird than the data I have? How extreme is my data in the light of the null? There are different words to be put on this probability. This probability is the p-value, which this procedure automatically gave to us here. Small p-value, rejecting, like we already realized, due to being left of the critical value. And it tells us which alternative that we chose. That's it for this part. Here we are. That's it. We jump to the next little